Hello, welcome to our webinar. This is Kanda speaking. We will start soon as possible. We are still waiting for attendees. And thank you for your time. Thank you for your patience. Let me introduce the webinar subjects contents for today. We will talk about industrial solutions and we will start with boiler house problems. After that, we will talk about some industrial problems, which includes food and beverage, textile, laundry, dyers, corrugated cardboard, oil and gas, and we will share our documents to you, and we will make some question and answer part. You can ask in any time with using chat screen. You can ask questions or you can ask directly from the question screen. We will continue just in a few seconds. I guess to respect you all, I will start right now. Now, let's start. The boiler room application, it starts with equipment selection. And it starts from the aerator to the steam trap unit under the collector header. It will start with the aerator, magnetic level gauge, and it will continue with boiler, sampler, surface and bottom blowdown, and etc. Basically, all equipment is here, as you see. We can support you, such as valves, safety valves, level control, surface, bottom blowdowns, feed water systems. You can also find this technical drawing and this selection chart in our catalogs. As the deaerators, let's talk about why do you need to use deaerator. In a lot of factory, I make some audits and surveys. In audits, we saw that 90%, not 90, 80% of the factories have deaerator tank with working at temperature 80 degrees Celsius. But it should be over than 102 to dissolve all oxygen from the system. If it's less than 102, it means it still has oxygen in the line. And that oxygen will cause pitting corrosion. Not kind of surface corrosion, it will cause pitting corrosion. This oxygen makes some tiny holes, and these holes will make some discharge leakages. That's why deaerators should be above than 102. For my advice, it should be 105 degrees Celsius and at least 110 degrees Celsius. Our compact deaerator head can mount to the feed water tank, or if you have another deaerator tank, it can also suitable with deaerator tank. And capacities can be changed according to size, from 5 tons to 30 tons per hour. It can be changed, and the length of the immersion tube can be also suitable. This is what happens if you don't use deaerators on your lines. The heat exchangers tubes can be with hole. The steam traps body cover can be with hole. And also you can see from here, I would like to warn you about the noise. Let's see. As you see here, it's because of the pitting corrosion on the body. It can be also on the cover in steam traps. I want to make sure that you all see this video. Yes. This is because of the pitting corrosion. If you have problem with see this video, just inform me and I will send you all. And let's talk about feed water system. In common usage, there are two types of feed water system. One of them is on-off feed water, and the other one is proportional feed water system. It depends with the investment cost. It depends with the usage area. You can use on-off feed water or proportional feed water. Let's see the differences. In on-off feed water, it can reduce the temperature because the system, when reach the low level, the system will fill with huge amount of water, huge quantity of water, huge liters. For example, for 300 liters suddenly gets into the boiler, and it will reduce the temperature, and also it will make pressure drops with on-off control. And also you will need more heat to raise the temperature up again from, in this case, from 125 to 165. And also with proportional feed water, it will be like this. You will feed the boiler proportionally, step by step, and it will not cause the pressure drops or temperature drops. All temperature will be same, all pressure will be same in the boiler room, and it will prevent the water draggings to the system, and it will prevent also the water hammers in the system startup. It works like this. The proportional feed water system works like this. The three-way control valve, diverting type control valve, will change the direction of the water according to signal of the level probe. And this level probe is working continuously, and it continues to change the water flow side. And pump will work continuously. Pump will not stop ever. But in on-off feed water system, pump will start and pump will get off. It will be on-off working period. And it will take signal with ALK4 probe, 4 probe of level probes. And in that case, control valve will start and will be on use properly, but pump will be on or off. And it will reduce the pump's lifetime, and boiler pressure and steam amount is not suitable. That may cause draggings, as I told you. Individual feed pump required for each boilers as reserved. It means you will need second pump to make it reserved. The feed water system differences, it's like this. One of them will give signal continuously, this level probe, because it's capacitive model, KP01. And the other one has 4 probes to give signal. The highest one is high water level, the lowest one is low water level, and you will control the level of your boiler with second and third one, pump off and pump on level. The advantage of the blowdowns. Let's talk about the blowdown systems. Until so far, if you have any question, please don't hesitate to ask. I will reply them all. Just write it. Let's talk about blowdown systems. Blowdown can make with automatically or manually. But if your factory makes blowdown manually, it means you will have some unkind energy waste, or you will have some more wastewater. This is what I mean. If you make this blowdown too much, it means you will reduce the TDS amount too much, and it will cause exactly the shiny, brighty boiler, but it will also cause the waste of water and waste of chemical that you add to your boiler, and the waste of energy, because you need to heat up again that much water from feed water tank, from makeup water. You need to heat it again. But if you make less blowdown, it means you will add more particles, more solids to your system. Yes, somebody questions. I'm checking. Nobody's. I'm checking the chat screen. Nobody tells nothing. Let's continue. And the boiler's conductivity must be 7,000 microsiemens per centimeter, less than 7,000 microsiemens. And for steam generators, it should be between 3,000 to 5,000 microsiemens. And you can see from here the surface blowdown and bottom blowdown applications, because the surface of the TDS level of the surface and TDS level of the bottom are different. We need to control both of them. With the help of this T connection, conductivity probe will gauge the conductivity level of the surface and take the unkind dissolved solids from the system to the drain line. And you can also use to this drain line flash vessel tank system and to get more energy efficiency. And you can use this flash steam maybe in the deaerator. And with bottom blowdown system, it should be also automatic, and it should be generally 3 seconds per working period. It means 3 seconds for 8 hours. Steam header and collector design. We will continue with steam header and collector design. The steam header's main body should be, actually steam header's condensate packet should be same with steam header's main body size, from DN15 to DN100. But from DN125 to 200, it should be 100 millimeter. Above the 250 millimeter, it should be half of it. For example, for DN300, it should be DN150. And you need to calculate your collector size, main size of your collector, with D1 square plus D2 square plus D3 square plus DN square, and you need to take all of them square, and you will find the exact dimension of your collector. Yes, we have one question at back. This graph is automatic blowdown system, and this graph is manual, because in this graph, as you see, it cannot hold between average and max amount of total dissolved solids. But in this graphic, you can make it stable in between average and maximum TDS level. This is for automatical blowdown. This is for manual blowdown. That's why if you make more blowdown than you require, that you need, you will lose more water of waste, more energy waste, more heat loss. But if you make if you make more blowdown, you will also discharge more than, if you make less blowdown, sorry, pardon me, if you make less blowdown, you will use more dissolved solid water to your boiler, and it will cause some layer of the sulfate, some layer of the minerals, etc. And it will cause more bubbles, and these bubbles will make the isolation curtain, and it will cause heat cannot pass to the boil steam, and it will cause less efficient system to your line. So piping and installation for steam lines. This is the most important thing of the efficiency. Let's check. For example, in steam lines, distribution lines, the amount of steam, for example, 10 ton per hour. It means the boiler capacity of your system is 10 ton per hour. And the pressure is 6 bar. What should be the appropriate diameter of pipe? Let's have a look. You can find this in our technical catalogs, in our technical handbook, or in internet. You can find this chart everywhere. In that case, at 6 bar, you need to check the 10 ton per hour. But as a design velocity, it should be 25 meter per second, because the steam's design velocity can be between 20 to 30 meter per second. And for this chart, its best velocity is 25. At 6 bar, 25 meter per second steam can pass from DN200 about 10 ton per hour. So this is your steam piping line measurement. So it means your main steam line's diameter should be 200 for 10 ton per hour, 6 bar steam. If it's more than 200, if it's 250, it means you will have some slow steam. That slow steam, the velocity of steam will be reduced, and that slow steam will give its heat to the pipes, and it will cause energy loss. And this energy loss will cause efficiency loss. So let's continue. We need to prevent this efficiency loss. As you see here, if you use at 6 bar 250 dimension, DN 250, it can pass 17 ton per hour, but we need 10 ton per hour. If you make it less, let's check. If you make your piping with DN 150, it means you will only have 6 ton per hour in theoretically, and you will push hard to your pipes, and it will cause vibrations in your system. It will cause high steam velocity in your system, and all will cause water hammers. I know that you hear a lot of noise in your system, in your piping, kind of pad in your system, a lot of noise, and this noise will cause water hammers, and it will damage all your expensive equipment. So in all case, in all installation, you will need exactly that you require, exactly that you need. If you need 10 ton at 200, you need to use these parameters. Let's move on, let's continue. Yes, this is frequently asking question to my side from my clients. I want to add it to the webinar. Separator selection. For example, if the steam amount is 2 ton per hour, and if the steam pressure is 10 bar, and the velocity of steam, as you know before, it will be 20 meter per second. Let's check. We will start with 10 bar because the steam pressure is 10 bar, and we will reach the line which is 2 tons per hour, this line from A point, and then we will continue to define the velocity of the steam, and it should be more than 20, less than 30, and it hits the DN80 line, as you see here. And then we will check if DN80 is good enough with pressure loss. We will check to the C point, to the C line, and we will find the D point. And if the D point is 0.05 bar pressure loss, maximum allowable, it's okay for us. And here is your separator, DN80 SPR16B. To make it clear, I will repeat it. First, you will make line from your steam pressure. By the way, you can find this diagram in our catalogs. And after that, for this case, it's 10 bar. And after that, you will hit the 2 tons per hour. If it's 4 ton, you need to find this point, for example. If it's 1 ton, it will be this point. And after that, you will find your separator's diameter, and then you will check the pressure loss, if it's acceptable or not. That's it. That's it for separator selection. And after that, when you select the separator, you need to focus the other equipment, because the only separator means nothing. You need to discharge the condensate from the below or inside the separator with steam trap unit. You need to discharge the air which stock inside the separator with air drainer. You need these two, steam trap and air drainer, to your separator application. In a lot of cases, I always see this steam trap unit, but I never see this TKK11 thermostatic air drainer. They feel like it's unnecessary, but it's necessary as much as your guest. And we will see why it's necessary in our, we have question. What if is out of acceptable pressure loss for separator? Good question. Let's continue with the question. Sorry. Just wait. If it's out of the allowable pressure loss, it means if it's above this line, this 0.05 line, if it's above than it, it's okay. It means you have less pressure loss. So it means your system works properly. But if it's more than 0.05, it means you need to count this pressure loss in your back pressure. Because 0.1 bar, for example, 0.1 bar means 1 meter length of the steam column. It means 1 meter length from the ground to the top. It means you need to count it when you calculate the back pressure. It's a lot of, that's why it's unacceptable. But if you don't have anything to do, for example, if you have 10 ton, let's have a look. If you have 10 ton per hour at 18 bar, or which one can be at, yes, at 20 bar, if you have 10 ton per hour, it means you need to use DN125. But at 20 bar, as you see here, at 20 bar, 0.1 bar is quite equal to 10 bar, 0.05 bar. The average is same, so you can use it. It can be allowable. In that case, if it's 10 bar and if you use 0.1 bar, it's unallowable. And also it cannot allow the steam flow rate. As you see, if it's 0.1 bar in same period, it should be here, and the C point should be here, and it's, as you see, it's 30 meter per second. It's on the edge parameter. So as you see, you cannot select DN80 in that case. That's why you need to be in allowable parameters. Otherwise, you can use it. So let's continue with line end applications. It's for general industries. It's for all industries actually. Because do you make the separator for 32 bar at 300 degrees Celsius? Let's talk about it after this conversation. We have SPR 40. So it means PM40 class separator we have. That's why we can talk about it later, okay? For now, I will continue. Why my dryer, which is cooking boiler, can be dye tank, SunForce, exchangers, etc. at the end of the line cannot heat efficiently while system startup. Let's be honest, in every system, at the end of the line, there is a machine with working inefficient. Because in that systems, all steam comes directly to the end, and all steam turns to condensate, change the phase and becomes condensate. And all these condensate can fill all these pipe, and this condensate can push with the steam to this machine. And generally, if your system has system start and system stop, for example, if you make holidays in weekends, or if you have traditional holidays, you are closing the system. And when you close the system from the pipe, your 6 bar steam turns suddenly to atmospheric water, atmospheric condensate. And all these condensate will make some blanks on the pipe, inside the pipe. And all these blanks must fill with something. With what? With air. Because there will be vacuum. And if you don't use vacuum breaker, it will take all air from the gaskets, which is between two flanges. And in many applications, you can easily see the gasket leakage. With that noise, you can see the leakage from the gasket. It's because of this, because your system don't have any vacuum breaker. And all this air comes to the system from your gaskets, and it will damage to your gaskets. And second period of this problem, when you fill all this air to your system with the help of the vacuum breaker to prevent the vacuum, after the holiday, you will come to your factory, and when you open the steam, this steam will face with air right here, because all condensate will discharge from the steam trap and all air will lock here. What you need to do, because this thermodynamic or bimetallic steam trap cannot discharge air properly, because the air will try to reach to the top, and it will prevent the steam to reach to the steam trap, to reach to the machine. What you need to do, you need to use air eliminator in your system. First, vacuum breaker to prevent vacuum, and then the air eliminator to prevent this air to face with steam. If you use these two equipment, you will have more efficient usage for this last machine. It can be cooking boiler. For this case, it can be yarn dyeing tanks, SunForce, heat exchangers, and etc. What you need to do, you need to use these two and this steam trap equipment. Temperature and pressure reducing valves. This is actually main ideal gas formula. P times V equals nRT. In that case, P is pressure, V is volume, N is moles, it means mass, weight of the steam, R is gas constant, and T is temperature. For closed system, for closed steam applications, V is, you can count as 1 because V is constant. In closed application, V is equal with your application's volume. N is also constant. For your case, if it's 2 ton per hour steam, it means 2 ton per hour for your system. R is also gas constant. So all these ideal gas formula turns to delta pressure equals delta temperature. It means that's why you only have temperature control valves and pressure reducing stations, pressure reducing valves. You don't have any weight control valves, etc. You have in applications temperature control or pressure reducing valves. It means these both valves can work instead of each other, but the working principles are different. We will focus the working principles. For temperature control valve, you can use proportional or on-off control valve or etc. With proportional, you can close your valve properly, averagely. As a percentage base, you can close or open your valve. With on-off, you can close your valve with on or off. For PRV, you have a lot of different types. Pilot operated, spring type, manual control, PRVs, etc. We also have in our product range pilot operated, spring and manual operated types. What is happening in heat exchangers? In that, with the help of with the usage of the temperature and PRV, this is happening. You are taking all this steam and directed to your tube type heat exchanger or plate type heat exchanger in that case with 130 degrees Celsius with the help of this gauge, temperature gauge, thermal camera. You see the 130 degrees Celsius in the valve, in temperature control valve, but you will see the 54.3, or it can be depends with your system, at your steam traps. As you see here, 105 degrees Celsius, heat exchanger is with 61 degrees Celsius, and the steam trap is only 52 degrees Celsius. Why it is happening? By the way, it's happening in all heat exchangers, in whole heating process, in all around the world, in all your factories. Why? Because even the temperature control valve or pressure reducing valve, if you use generally temperature control valve in that case, it has set temperature. For example, for this example, 70 degrees Celsius, and your product is 30 degrees Celsius. Your feeding steam is 4.5 bar, it means 145 degrees Celsius. When you reach the adjusted temperature properly, averagely, when you reach 35 degrees Celsius, your temperature control valve will reduce the temperature, will reduce the flow rate of the steam. And this reducing will cause the pressure drops. And if it drop to the 2 bar, in that case, your heat exchanger's heat load will reduce 20% less to the 80%. And when you reach to the 70 degrees Celsius, the heat load will reduce properly, and it will cause condensation in the tube type heat exchanger or plate type heat exchanger. it means efficiency loss. What you need to do, let's have a look. With IVAS plate heat exchanger, product comes to the system. It controls with temperature controlling valve, and it's using steam from main steam line. And steam trap cannot take this condensate to the system, to the condensate recovery line. Why? There is no pressure. If there is no pressure, it cannot push by itself. You need to use steam power pumps or steam condensate recovery pumps, like our model. It is ECOP steam condensate transfer pump, and you can use this ECOP with 3 or 4 of your heat exchangers. As a room base, you can use it. If you have, for example, for food industry, more than 3 or 4 CIPs, cleaning in process, or pasteurization tanks, or if you have for dyeing industry, if you have dye tanks, if you have dryers, washing machines, etc., you can push all this condensate with condensate transfer pump for room base. You can check all this main steam feed. With the help of the main steam lines pressure, you will push all these condensate, and there will be no more condensation, and according to this, there will be no heat loss and no exchanger heat load loss. Let's have a look at the corrugated cardboard industry for a short. These are the cylinders that stamp the layer of the corrugated cardboards. It means generally it can stamp to each other with 2-ply or 3-plies. It depends with the cardboard's type. It can be B type, C type, E type, A type, Z type, etc. And for that, they will need heat. And if anybody with us with corrugated cardboard industry, they know that sometimes the corrugated plates can be with some expansion, and it is because of the efficiency loss. If you want to use 140 degrees Celsius in that cylinder, it means you need to use exactly 140 degrees Celsius. If it's above than 140 degrees Celsius, it will be more dry. And this dry and this wet, this humidity will cause these expansions. To prevent it, you need to use correct application. You need to discharge all these condensate from the siphons with the help of the siphons to the condensate outlet. With the help of the correct steam trap, which is free flow type steam trap, not the others. In generally usage, because of the design, they are using inverted bucket type or thermodynamic type, or some cases thermostatic type, but all are unnecessary. You need to use free flow type. For cooking boilers, for food industry, or you can just count it with chocolate melt industry or pasteurization tank, or it can be milk industry, milk boiler. You need to use float type steam trap with this other help equipment, with control body or with check valve, with strainer, and with flow side glass. Sorry for this is not flow meter, this is side glass. And you need to use also TKK 61 gas for what? For discharge air inside the system. Because in that case, generally they are using with a temperature controlling valve, and they are cutting the temperature, they are cutting the pressure when the cooking process is finished. And when they cut it, what will be? There will be vacuum. To prevent this vacuum, you need to use vacuum breaker, and after short time, they will open it again. To prevent this air out, what you need to do, you need to use air drainer. So you need to use vacuum breaker and air drainer board in the cooking boilers. You can find this catalog in our technical handbook, and you can find this catalog with the asking of us. As you see here, in some food processes, the condensate amount you can calculate with the capacity chart. I add this chart, I add this information because a lot of people ask for it. They are asking for the average condensate amount because they only know the average steam amount, which is the pasteurization or oven need. So you can calculate with this as averagely, and you can find your steam trap. We will make some examples. For example, for dyeing paint tanks, you can check the capacity. If it's 50 kilogram, it means if it's closed system, 58 kilogram per hour steam consumption, it means 58 kilogram per hour condensation will be here. So according to this knowledge, you can select your steam trap. Generally SK51 for that case. For laundry, you can also find, if it's open or closed application, you can find the amount of your condensation. For dryers, for industrial irons, you can select thermodynamic steam trap because the condensation amount is too less, and you also have air drainers in your steam irons. That's why you can select for model blowers, for robot irons, for steam irons, or for trousers, thermodynamic steam traps. And for corrugated cardboard industry, also with closed condensate system, 0.12 kilogram per hour for meter cube of the corrugated cardboard. You can check, you can print screen, that's process screens. And hygienic applications for industries. Let's continue with hygienic applications for industries. There is 4 type of steam purity range. Plant steam, it's for general usage, which you can use in HVAC, textile, petrochemical, in food industry, in etc., in everywhere as a plant steam. It means your steam is plant steam. But in some cases, you need filtered, clean, or pure steam purity. For food and beverage, in bakery, to make more shiny breads or make more quality breads, they are using steam directly injected to the bread, to the flour. It means you cannot use plant steam because it's harmful to human body. What you need to do, you need to make it pure with filter or with clean purity range in food and beverage. But sometimes they say that there is nothing to survey our site. Nobody makes some purity in our site, but it's unhealthy. Because of this, please be careful. This is human life. According to Corona issue, you know better than us about this issue. So if you need pure steam, please use it. But how can you make pure steam? With the help of the hygienic steam generators, which is one of them, is, as you see here. It uses plant steam and it turns the pure water to the pure steam, or it turns the clean water to the clean steam. And you can use it in hospitals, in biotechnology, pharmaceutical, or food and beverage industries. And with IVAS, we can provide you from 150 kilogram per hour to the 4 tons per hour unit range. And also, you if you have small applications, you can use hygienic heat exchangers, which is all materials are titanium or all materials can be 316L manufacturing. And also, you need to use stainless steel steam trap in that applications. You can use this thermostatic stainless steel steam trap, or you can use our SK61 types of steam traps. It's fully stainless steel, or TKK42 steam trap, thermostatic for air releaser right here. Oh, sorry, right here, somewhere right here. And you can use SK61, as you see here, as a stainless steel, all body and particles inside. For paper mills, and actually this is only cylinder dryers. It can be paper mill, it can be textile industry for dryer, or it can be Sunfor or etc. You need to use SK51 SLR, or you can use SFK40 free float type steam trap. You need, in that case, we need to show you that you need to use for every cylinder one steam trap. You cannot group all of them to one. You need to use separately for each. You need to take steam to your cylinders like this with branch, not directly from below, because if you take steam directly from below, it means you will take all these condensation to your cylinder. You need to take with branch. This will gain to your efficiency, by the way. Yes, in that case, if you make group trapping, it will happen. When the steam reaches to the steam trap will prevent the steam leakage to the next of it, to the side of it. But when it's locked down, when it's locked, if there is any condensation, it will not pass. This condensation will not pass through the steam trap. Why? There will be steam. And it will make heat loss, and it will make the capacity of the heat exchanger or the cylinder loss. What you need to do, you need to use separately steam traps. For Sunfor, for example, in that case, as you see here, the group of steam traps. There's there are four Sunfor cylinders, but only 2 steam traps. It will make efficiency loss. And in that case, as you see here, there will be some bellows in the, some elbows in the flexible metal hoses. You need to use with elbow type flexible metal hose with completely stainless steel, 316 or 304. Braided type flexible metal hose to connect siphons to the steam traps. And also the common mistake is inverted bucket type application. The body of the inverted bucket type and free float type is quite same, but the working principles are not same. Air can lock this inverted bucket type, and you need to wait air lock, air drain, air releasing hole work properly, and you will waste time and condensation will collect inside these cylinders. Instead of inverted bucket type, you need to use free float type because it will discharge air and condensate both together. In that case, every steam traps are inverted bucket, but it's all wrong. Generally, they say, the clients say that it's from the original. It doesn't matter if the original application is correct or wrong. It's matter to your application must be correct. That's why if you have in your cylinders this type of bucket type of steam trap, just focus to the design differences. you need to use the free float type. It makes differences. It will raise your efficiency about 10% for that machine. And also grouping, as you see here, for example, the 2 plates heat exchangers is on the top of the dryers, on the tumble dryers for textile industry in that case. And there are 2 inlets for heat exchangers, and there should be 2 outlets with 2 steam trap units. If it's with 1 steam trap, if there is there are condensation for one of them, and if there is fully steam for others, and if this steam will reach the steam trap, this condensation will cause damage and will cause heat drops, heat loss, energy drops in this steam heat exchanger. To prevent this, you need to use 2 steam traps, which is float type. You need to use float type steam trap in heat exchangers. As you see here, the third photo, they use thermodynamic steam trap. And if there's any air inside the heat exchanger, this thermodynamic steam trap will not prevent this air, and it may cause the air loss inside the heat exchangers. And also steam trap position. You need to check the position of the steam trap. If the steam trap position is wrong, it means it will be in open position continuously, and it will cause steam leakage. It will cause efficiency loss. We start to produce our steam traps with smiley faces, smiley icon, to make it a good show. As you see here, if it's smile, it means your position of steam trap will correct. This is new. You can ask for your sales representative for your new request, for your new inquiries. So for oil and gas industry, you can have 2 types of manifolds. One of them is for steam distribution, which is this one, and one of them is for condensate collection. And for this condensate collection, you can use these universal type steam traps with float type or with thermodynamic type, and also with thermostatic or bimetallic type. The body of the valves are same, but the cover of the steam trap part are different. And this is manifold, and in that case, this is for steam condensate collection manifold. This is also. And you will add these steam traps to the side of the pipe. And for trace lines in oil and gas industry or fuel oil industry, in trace lines, you need to use bimetallic steam trap to prevent overheated steam issues, and to use more energy in the steam line. You need to use TK1 or TK1A. I will make clear the differences of TK1 or TK1A. In that case, as you see, you can adjust TK1A with only unmounting this adjustment cover. On the other hand, to adjust standard TK1 bimetallic steam trap, you need to unmount this main cover with unmounting these bolts, and you need to reach this adjustment stem to calibrate your steam trap. But to do this, you need to stop your steam system. It means you need to stop here. You need to open bypass, and you need to discharge all your steam to the bypass line. and it will cause a lot of money waste. To prevent it, you can use TK1 adjustable. With this adjustment cover and stem, you only need to unmount this cover to reach this stem, to adjust with only screwdriver, to calibrate your discharge temperature, and you can close it again easily. And it will prevent this energy leakage. For industrial boiler tanks, as you see here, in that case, they use thermostatic control valve. You can count it as a milk process, yogurt process, or dye process, etc. For generally, you need to use one thermostatic control valve, and vacuum breaker, an air releaser, air drainer, and steam trap unit. All these equipment are necessary to make efficient. If you don't use vacuum breaker, there will be gasket damage issues, or there will be vacuum issues on the system. And according to this vacuum issue, the product can mix to your condensate. The product can mix to the steam, and it may cause a lot of damage to your boiler also. If you don't use air drainer, it means there will be air inside your line. If you don't use thermostatic control valve, you cannot control it. It means every system has its own balance. So you need to protect this balance to protect your efficiency. For SunForce, for example, in that case, for textile industry, all these red lines has steam, especially these two SunForce machine with cylinders, heating cylinders, as you see. For example, for flexible metal hose application, some cases, some clients are using this flange type, and they are using this flange connection directly to the valve. But if you do like this, as it's shown, there will be too much elbows, too much turns in the flexible metal hose. And according to water hammer, according to water dragging, there will be leakage, there will be damage. To prevent it, please, we kindly advise to use flexible metal hose in same line, not in elbows. Turn it with some elbow, T connection, etc. And after that, use flexible metal hose. It will be better to use. Because in that case, these flexible metal hoses is not for elbows. These are for vibration absorption. And also, in fabric dyeing tanks, the process is like this. 40 degrees Celsius in 15 minutes, and after that, rising temperature to 80 and 130. It means there is three level of temperature. It means the temperature controlling valve will change the temperature to the 3 level. There will be a lot of pressure drop. To prevent this, what you need to use? You need to use steam condensate transfer pump. It means there will be a lot of pressure drop. But for dyeing tanks, according to capacity, 25 to 35 kilogram per hour steam consumption will be. And 6 to 8 bar working pressure, it's acceptable for dyeing tanks. If your dyeing tank is using more or less pressure, it's up to your capacity. As a standard average, it's like this. For yarn dyeing, it's also quite same. So this is another problem in all system. For pressure reducing valve selection, we will make one example, and I will explain it with this one short example, how to select your pressure reducing valve. This is for BDY 25 IVAS pressure reducing valve. For another models, you need to check the catalogs. You will find this chart. For example, for 10 ton per hour and 200 kilogram per hour steam capacity, for that example, and the 10 ton per hour, 10 bar, let's start again. For 10 bar and 200 kilogram per hour steam, you need to use pipeline DN25. It means from your main steam line, if you want 200 kilogram or 250 kilogram at 10 bar, you need to divert it with DN25 line. And if you want to reduce the pressure to the 5 bar, you need to continue, this is important, you need to continue after pressure reducing valve with DN32. This is most critical thing for pressure reducing valve. Your start pipeline is 25, was 25. But now if you reduce the pressure from 10 to 5 bar, and if you want the same capacity as you see here from 200 kilogram, and if it's continue with 200, you need to raise the diameter of your pipe to the 32 bar, 32 at the end, sorry, not bar. And also, that's why in piping instrumentation diagram in PNIDs, pressure reducing valves entrance triangle is shorter than outlet triangle. That's why inlet triangle is smaller than outlet, as it's shown in drawings in PNIDs. So inlet size of pipe is DN25, outlet size of pipe DN32. But let's have a look at the size of the pressure reducing valve. To the 5 bar, from 10 bar, and as you see, to reach the 200 kilogram per hour, it should be 3/4 or DN20. What it shows us, the inlet pipe diameter is different with outlet and also different with pressure reducing valves diameter. It says a lot. You can just count it like this and you can just apply in your pressure reducing stations. If it's pilot operated or as you see here, spring operated, it can be DN100 as yellow, it's shown, or it can be DN200 as it's shown in red, or it can be DN50 for green. That's why when you inquire steam pressure reducing valve, the inlet and outlet pipe diameter is not enough for us. We need to know the quantity of steam and we need to know the pressure of inlet and outlet. And we will select your best steam pressure reducing valve to you with help of these technical diagrams. So if your system is DN100, if you want to use DN100 pressure reducing valve, it may be higher than your adjustment. So it can be expensive. It can be expensive cost to your investment. This is critical and important thing for piping diameter for PRV. This is one wrong application, as you see. Pilot operated PRV with same size of inlet, same size of outlet, and same size of PRV. Maybe it will be enough two size low PRV, and it will make less expensive. It will be cheaper. So this calculation, that's why it's so important. So let's continue with steam trap selection. We need to know the type of the equipment. we need to know the steam pressure before steam trap, steam pressure after steam trap, and amount of condensate. For heat exchangers, you can double it with 3 times more, and for other applications, you need to double it with 2 times more to condensate amount to make it safe. Let's have an example. The type of the equipment, heat exchanger of tumble dryer, and for 150 kilogram drying process. And steam pressure before and after, it's 5 bar and 0.8 bar back pressure. Let's have a look. First, we need to check from the catalog of your equipment. First, you need to check the equipment catalog about the consumption of steam. If you don't have catalog, if you lose your catalog, you can check from internet or you can check from our catalog. For 150 kilogram, in closed application, condensate is 136 kilogram per hour. So you need to double it with 3 times. And 408 kilogram per hour condensate you have in your dryer. The second, you need to check the heat exchanger. And it says float type, floating ball steam trap from the other catalog, from the selection catalog. So now you know that you need SK series float type steam trap and you need 400 kilogram condensate discharge. Where will you look for third part? You need to check the catalog, technical catalog of the steam trap, of the float type steam trap in that case. The differential pressure is 4.2 because the inlet was 5, the outlet is 0.8, and the differential pressure is 4.2. So for 400 kilogram per hour capacity, you need to select, because of this point, you need to select in that area. And it means it can be SK51 float type steam trap, delta pressure 4.5, and it can be half-inch or 3/4 according to line size. If it's 3/4, it can discharge more, but as you see here, half or 3/4 is quite same. You can select more according to line size. If your line comes half-inch, you can continue with half-inch, or if it's 3/4, you can continue with 3/4. Now, I'm waiting for your questions. For today, that's it from my side. And now I want to warn you for some things. From handouts screen, you can download all our new catalogs for boiler assemble, for corrugated cardboard, food beverage, heat exchanger, and laundry. You can download all of them. And now you can ask me questions. Let's check your questions from here. Where is your question screen? It was here. I'm waiting for your questions for a short time. Who should we send the heat exchanger inquiry to? Please give us, yes, we have some questions. Let's check. Thank you. Very heavy condensation condition. What is the solution to remove heavy condensation from heat exchanger? The solution to remove heavy condensation from heat exchanger has 2 ways. If I understand your question correct, you can use condensate transfer pumps. It can discharge up to 16 tons per hour. But if you don't have any stall issue, which I mentioned before, the heat loss in the steam heat exchangers, if you don't have stall issue, condensation issue, you can use float type steam traps. In IVAS range, we have up to 30 or up to 40 ton per hour discharge capacity float type steam trap. which is SK50B. Type name is SK50B. The dimension is 2 inch. You can control the chart. It's up to 30 or 40 tons per hour. This other question, in pulp paper industry, they have requirement for heat exchangers, which are very corrosive and require fully lined. Do you have any? Yes. Yes, mister. You can ask your sales representative, and I kindly warn you to mention me. I will write to chat screen my personal email. Let's wait. Yes. See, I'm writing right now. Yes. crenklidere@ivaz.com. Instead of this minus, you need to use crenklidere@ivaz.com. Please forward to me your heat exchanger requests also. So let's continue with questions. If I find the question screen, yes. What about the beer industry's heat exchanger? What type of steam trap is more efficient? The other question comes. Thank you for this question. For beer industries, if the product gets inside to this heat exchanger, it should be stainless steel type and FDA certificated, etc. And for steam trap, if it's after the heat exchanger, it can be our SK61 material. It means 316 material, stainless steel material steam trap. It can be SK61 or TKK42, 41. It can be SK61 with high demands, high size or less size. It can be. Or for some main pure steam lines, it can be TDK71. It's also stainless steel with all spare parts are stainless steel. So for beer industries, for thermodynamic, TDK71, it's okay. For thermostatic, HTT6, our hygienic steam trap thermostatic, it's suitable. TKK42 and 41 is suitable. For float type, SK61 is suitable, you can use. And for others, you can use TK1A or TK1. And what about the heat exchanger of beer industry? I also answered, I guess. You need to use FDA certificated, for food certificate, or for brewery. You can use, if you don't need any certificate for FDA, etc., you need to use titanium plate or 316L plate, which is suitable with food and beverage. So you can ask for this inquiry to IVAS and please forward me. What is out of acceptable pressure loss? We talk about it. Which graph is out and which graph is manual? We talk about it. We have representative in South Africa. For Africa zone, we have representatives. Please ask your question after this webinar to me directly, and I will meet our representative, sales representative, which is my colleague from IVAS. I will give you the contact information. Who should we send the heat exchanger inquiry to? I guess I replied this. Why need to set bimetallic steam trap? Because in some cases, in trace line, etc. Let's answer your question. Just wait. Where is it? Why we need to set bimetallic steam traps? Let's answer your question. Because in some cases, especially in steam fuel oil line, trace lines, or if you use this TK1 instead of thermodynamic steam trap, or if you want more discharge capacity, you can use it in 20 degrees Celsius temperature differences. So you can raise the discharge capacity of the steam trap. In that cases, you need to adjust it. For example, if you use it in 5 degrees Celsius temperature differences, it can work as a thermodynamic steam trap. And you can, for example, if you use 20 degrees Celsius temperature differences, you can use more energy in your line. So, and also there will be more condensate collection before your steam trap, and it means the condensate amount of discharge will be rise. So according to these issues, according to system, you need to adjust in some cases, not all cases. I hope it's answer for your question. Your presentation is different in some details from the documents we can download, namely some examples and calculations. Is it possible to download your complete presentation? After this webinar, if you send us a request for this, I will send you our presentation. This is my newest presentation. That's why you can find differences. So let's continue. If you have any more questions, can you share our slides? Yes, I will share after this webinar, but just need to ask me about it. Do you make separator? I guess I answered all your questions. If you have more questions, I'm still waiting here. Otherwise, I will finish this presentation for today. By the way, thank you for your time. Please don't miss our next 2 webinars, because tomorrow we will talk about deaerators and selection. We will talk about again the heat exchangers. We will talk about flash steam recovery lines, flash vessel tank selection. We will talk about condensate transfer pump selection. We will talk about any different high efficiency selection of the technical equipment. That's why these are for steam piping selection. This webinar was for it, but for more efficient, tomorrow we will continue with other equipment selections. That's why if you don't make request, please do after this seminar. I'm checking once again your questions. I think, does IWAS produce ball float steam trap up to 32 bar? No, we are producing up to 25 bar, which is SK70. SK70 right now, I will mention in what's new in IWAS webinar, in third part of the webinar. SK70 right now has with delta pressure 21 orifice. It means up to 21 bar differential pressure, you can use SK70 from size DN15 to DN50. SK70, the forged steel body type, up to 25 bar. Does you deal in laundry system? For laundry, we mentioned for as you see, dryers, and also for irons, we mentioned it. But from handouts, let's check. You can find our laundry catalog. You can find our technical laundry catalog from handouts. Please download it. And if you have any question for piping instrumentation or for any other projects for your laundries, you can ask. For outlets, we have another question. For outlet pipe size after PRV, if we use the same size as PRV, besides it will affect the downstream capacity, will it also cause high back pressure? If you use same, and if the same size is not enough, it will affect the downstream capacity, but it will also affect the velocity of steam. It means steam tries to reach your request, and it will cause vibration in your system. And not high back pressure, but it will cause more water hammers, more vibration, more voice in your system, and it will cause water hammers. But if it's less than your request, it's also dangerous. If it's less than your request, it will cause efficiency loss. It will cause heat loss. So both of it, if it's more or less, it will cause different complications, different problems. For steam trap SK, yes, this is important question I'm repeating right now. For steam trap types, SK, we have different types, thermostatic capsules, which is S, H, and L. How we must choose? S is standard. It means 10 degrees Celsius temperature differences. As a standard, it is S. If it's high, it means 5 degrees Celsius. If it's low, it means 20 degrees Celsius. If you need high discharge, you can high difference is 20. Low difference is 5. It's up to this. So you can select S, H, and L. But right now, we will mention what's new in IVAS, third part of the webinar on Monday. We have bimetallic discharge element. Instead of thermostatic capsule, right now we have bimetallic as an optional, not as a standard. As a standard, we have 3 types of thermostatic capsule. How to determine orientation of steam trap for earlier supplied steam traps without smiley symbol? Please ask your customer representative. I answered. Sometimes, another question, I found broken bolts float type steam trap, like hole behind the steam trap. What happened? This is water hammer. If the system is not safe, it will cause water hammers. It will comes with high noise. In that broken ball, there should be water hammer. I already have photos of many of it. Just ask after this webinar about it. Let me check once again. Yes. I will make it if I answer. Yes, I answered. I'm checking right now the questions. Do we have chart showing our model and equipment for other brands? Yes, we have. You can ask for it to your customer representative. I answered this SPR question. Free float type without level, yes, we have. SFK series, our models are free float type, SFK 40, SFK 61, SFK 70. Mister, you can ask from your customer representative. Temperature control valve, we have but limited model. You can ask your customer representative. I answered this. Yes, we can help to laundries. For outlet pipe, I answered it. This one I answered. How to determine orientation earlier in pulp paper, I answered. I guess I don't have any question to answer, but I'm looking once again to not miss anything. Which type of steam trap you recommend when delta pressure is very low? For this question, for example, for low delta pressure, you need to use 4.5 bar differential pressure, DP 4.5. But the minimum differential pressure should be 0.7 because of the weight of the float lever. If it's less than 0.7, you need to use different type of steam trap, which is thermostatic or thermodynamic. And unfortunately, it will affect the discharge capacity. You cannot find much more than float type. But I kindly advise you to use bimetallic steam trap. Just ask it, thermodynamic or bimetallic, for less that differential pressure. So I answer this. I should heat exchanger. Yes, I answered this. Any other? What is the maximum warranty? I was steam trap 2 years, by the way. Not 3 years for company policy. For now, not possible. But just ask your customer representative and see what can he do. Indicator to be installed before or after. Flow indicators can be installed before or after. It depends with the steam trap type. For float type, before float indicator is better. But for example, for thermodynamic type, after steam trap is better to use. Because in thermodynamic type, there you will see 5 times in 1 minute. Open and close itself. It's easy to see after steam trap. For sight glass, I'm talking. But for float type, before steam trap, it's better to use. What is the use of air vent in float type steam trap? As air ventilator, as air discharge, we are using thermostatic capsule that I mentioned, which is H, S, and L, or we are using bimetallic element. We have both of them as an option. Any other question? Yes, I replied it during the webinar. I replied it. I guess I finished all your questions. I will share this webinar notes to you all. Thank you for your participation, and please fill the webinar poll. Please fill the webinar questionnaire after the webinar, and please be attending tomorrow's webinar also. Tomorrow's webinar is also very important. Thank you for your all attention. Thank you for your all great questions. Thank you for your all patience and time. I hope to see you tomorrow's webinar again. Thank you and goodbye.